If you print a Pikachu, your boss will immediately come find you. When you want to extrude carbon fiber materials at high speeds, it is generally difficult to achieve. There are two solutions to this problem. The first is to reduce the carbon fiber content proportion, which can help solve the issue. The second is using low-speed or slow printing methods for carbon fiber. It's the other solution. Additionally, carbon fiber tends to wear out the nozzle. Whether you're using brass or hardened steel nozzles, high-speed printing of carbon fiber will easily wear them out, shortening their lifespan. Besides, if greater extrusion force is needed, a direct drive or servo motor is generally required, which increases the cost. Another point is the quality of the printed parts. When printing with short carbon fiber, the surface may show fuzz or filament-like projections, commonly referred to as fuzz. These are actually carbon fiber filaments floating on the surface. Moreover, when printing with carbon fiber, it is generally observed that the precision is lower than that of traditional base materials. This represents a classic impossible triangle. Achieving one aspect means compromising on the other two. This is the condition known as cold core during carbon fiber extrusion. When printing carbon fiber reinforced materials, the heating is not uniform between the core and the exterior. As a result, the core and outer carbon fibers are in different thermal states, with the core remaining at a lower temperature. This discrepancy causes internal carbon fibers to extrude at lower temperatures, leading to nozzle damage. Most carbon fiber clogs are due to this issue. HyperCore is a major breakthrough we achieved after releasing the HyperFFF 3D printing technology in 2022. I personally believe that HyperCore will be a future trend for the entire FFF printing technology. Yes, we call it HyperCore, or as some friends refer to it, core shell filament. The core of the filament is enriched with carbon fiber reinforcement, while the outer part is made of traditional materials like ABS, nylon, or other engineering materials. With this core shell processing technique, the material becomes suitable for high-speed printing equipment, exhibits excellent surface quality, optimizes thermal conductivity, and avoids cold core issues. This is the difference between HyperCore material and traditional short carbon fibers under an electron microscope. It's the microscopic image of a 1.75 mm filament under the electron microscope. On the right, we can see that each fiber during printing appears as if it is coated with paste. Therefore, during extrusion, it is no longer the traditional filament mixed with carbon fibers. So, how is its strength? As you can see, the biggest challenge when printing with short carbon fibers is in the Z-axis. The Z-axis stiffness and strength have greatly improved compared to the original. For carbon fiber, the challenge lies in the interlayer bonding strength, which is generally worse than PLA or ABS. However, with the HyperCore composite filament, we can solve this issue because the interlayer bonding strength is provided by the base material, ensuring a very strong adhesion. In the XY axis direction there isn't much variation compared to traditional nylon reinforced carbon fiber. However, there's a significant enhancement in the Z-axis. This is a comparison between HyperCore PPACF filaments and standard carbon fiber materials in terms of ultimate tensile strength, modulus, stress, and elongation at break. This is a comparison with standard composite materials. In terms of printing speed, currently, our hypercore filament prints at speeds over 200 mm per second. Typically, carbon fiber extrusion can only achieve speeds of 45 to 60 mm per second. Therefore, hypercore's printing speed is approximately 3 to 4 times faster than that of traditional composite materials. The quality, impact strength, and heat distortion temperature of hypercore material have also seen significant improvements compared to traditional materials, particularly in terms of HDT. I know that, in many high-temperature work scenarios, there is often a need for peak. In fact, our current observations show that materials like PPACF and PPAGF can meet high-temperature environments of 189 degrees Celsius, 188 degrees Celsius, thus being able to partially replace the need for peak. This is what we mentioned earlier, regarding the strength of the Z-axis at a printing speed of 300 mm per second. In terms of the applications for hypercore material, we can produce various parts, such as components, interior parts, end-use parts, and some tooling parts, and some personalized parts, applied in the medical field. We are launching 3 materials this time, PPACF25, PPAGF25, and ABS-CF15. One notable feature is that our carbon fiber content can reach up to 25%, which is difficult to achieve for short carbon fibers. Using core shell processing, we concentrate the fibers in the center of the filament. I believe that our hypercore material has achieved a strength level between that of short staple fibers to continuous fibers. This is PPACF with a carbon fiber content of 25%. PPAGF25 contains 25% glass fiber, which offers a better cost-performance ratio. As many of you may know, glass fiber is generally more economical than carbon fiber. This is ABS-CF15, which is the most commonly used and widely applicable. ABS, as a base material, has a broader range of applications. Therefore, in the automotive manufacturing sector, this material is preferred. The following is an introduction to our brand new 3D printing equipment. This is our newly released equipment, capable of continuous production of high-performance engineering filament. So, for this latest model, the first thing is, it can achieve high-speed printing of composite materials. This is the biggest feature of the Pro3 HS series. The printing speed can reach up to 300 mm per second, equipped with Raise3D Hyper FFF technology, supporting high-speed printing. Additionally, the Pro3 HS features auto-filament switching functionality, as you can see, with the hypercore material. We are currently able to increase the average printing speed of carbon fiber materials to 200 to 300 millimeters per second. Compared to the previous generation Pro 3 series, the Pro 3 HS can save printing time by 30% to 70%, depending on the size of the model. This is our printing comparison. If you're running a printing farm or providing printing services, you should be quite sensitive to this data. For the Pro 3 HS, when printing carbon fiber materials, based on our internal tests, it can handle about 1.3 kilograms per day. So, it's a production-grade device. This is the printing data for a standard fixture. With the Pro 3 equipped with a hyper-speed upgrade kit, printing takes 292 minutes. However, for the Pro 3 HS series, the printing time is further reduced, compared to the original Pro 3 with a hyper-speed kit. Closed-loop stepper motors. No need to delve into details. It's quite clear to everyone. They provide better precision control. This is an aspect that interests many people. Now, as you can see, many FFF companies are working on continuous filament feeding. Raise3D is a company specializing in industrial printing equipment, serving clients who are primarily enterprises and manufacturing companies. For manufacturing companies, the main challenge lies in whether they can provide continuous, uninterrupted filament feeding for long periods of time. Perhaps when I'm printing a large model, what if I run out of filament with only a little left? Can I seamlessly continue printing? That's the challenge. Our solution is based on our existing system, offering an auto filament switching feature, leveraging the advantage of our dual extruder printer. Once one nozzle runs out of filament, we seamlessly switch to the other nozzle to continue printing. This is an unparalleled advantage of having dual nozzles. Additionally, the Pro 3 HS is equipped with a 2.5 kilograms external filament box, allowing for 5 kilograms of continuous filament feeding in a single run. It can achieve up to 120 hours of continuous printing. This also meets the needs of many automotive manufacturers. For example, if they need to print a large steering wheel prototype, a single spool of filament might not be enough. What happens if the print runs overnight? In such cases, they can continue printing using the auto filament switching feature, ensuring uninterrupted printing. The RFID filament sensor can identify the filament, preventing the use of incorrect materials. In fact, it serves as a foolproof feature for us. Greater durability is something we emphasize a lot. For our products, we hope that customers can use them for 1 year, 2 years, 3 years, 5 years, or longer. We don't want customers to replace the equipment after just 3 months or after 5 months of continuous high-speed printing. We aim to provide customers with a long-term, effective solution. Additionally, the Pro 3 HS is very user-friendly. The Eve Smart Assistant helps resolve common printing issues. Furthermore, it features power loss recovery and automatic detection functionalities. Next is the Airflow Manager, and I want to highlight this feature specifically. The Airflow Manager function differs from the traditional HEPA purification method that many people might understand it to be. People may mistakenly assume they serve the same purpose, but they don't. The Airflow Manager operates with internal circulation, circulating and heating the printing chamber internally. So, many might wonder, you don't have a heated chamber, so how come you can print ABS quite well? Why does it sometimes perform better than solutions with a heated chamber? The reason lies in the Airflow Manager. It circulates warm air at the bottom of the printing chamber, maintaining an internal chamber temperature of around 45 to 50 degrees Celsius. Here is our self-developed slicing software, IdeaMaker. It is a closed-source 3D printing slicing software. For enterprise customers, this offers greater security. Additionally, in our latest version, we have included support for the DF2 DLP resin printer. This means that, with a single slicing software, you can perform slicing for both light curing and FFF printing. We have an intelligent factory management assistant called Raise Cloud. This is a crucial feature for many users. Whether you're a farm operator or a service provider for a printing factory, the ability to manage multiple devices is essential. So our online management system's logic differs significantly from that of consumer-grade systems. Here's a joke. These devices on the farm are tied to the enterprise, not to individuals. So if an employee leaves, they'll be kicked out of the management group. Unlike consumer-grade devices, which are personal, this is a completely different approach. It's a whole different ballgame. So when using consumer-grade devices, everyone faces a common challenge. For example, if I want to use a printer remotely today, I have to ask my teacher, classmate, or friend to send me the login password before I can use the device. With Raise Cloud, that's not necessary. Whether it's your print job or mine, everything is visible in the system. If you print a Pikachu, your boss will immediately come find you.